Section 1.4, perimeter and area in the coordinate plane. Our essential question, how can you find the perimeter and area of a polygon in the coordinate plane? We start with some definitions. So a polygon is a closed figure where each side intersects exactly two sides at the endpoints. So each side, each line only has two places where it meets something. If there's no meeting, if there's one, then it's not a polygon. If there's three lines intersecting, it's not a polygon. Sides, line segments that make a polygon. Vertex, meaning of two rays or line segments. So in our polygon, there are always going to be line segments, our corners here. The two rays, when we get into angles, which will be the next section, they're made up of rays. Those meetings will be vertexes as well. The plural of that is vertices. Convex, a polygon with no line containing a side with a point inside the polygon. Concave is defined as a non-convex polygon. So your typical polygons you're thinking of are probably concave polygons. Your concave polygons have some place where they go in. Okay, so something like this would be convex. There's no point where I'm going inside of my shape. Something like this would be concave. I have a spot where it goes in. Oop, and I can't see either of those. This is the convex one. This is the concave one. Normally, most people are fairly good at seeing those, but if you're questioning something, if you have a shape that's harder or you just not have a little trouble seeing it, one thing you can do is draw diagonals, which we haven't defined yet, but diagonals connect your non-consecutive vertices. So if I connect all my points, if everything is inside my shape, it's convex. If there's any line that's outside of my shape, then it is concave. So if you're stuck, that's a good way to check them. So then example 1 says find the perimeter and area of a polygon with the given vertices. So they give us T is 0, -2, U is 3, 5, and V is -3, 5. So T is 0, 2. Or I'm sorry, 0, -2, so T is there. U is 3, 5, so I come over 3 and up 5. And V is -3, 5, so I come over -3 and up that same 5. This is U, that's V. And that is my triangle. So, perimeter, I need to add up all my sides. VU, so I need VU, I need TU, and I need TV. Right? And you add all those up. VU is nice and easy. It is a straight line, so I can count, or I can look at my points. I'm going from 3 to -3, and that has a distance of 6. TU and TV are not, well, they're straight lines, but they're not vertical or horizontal, so I can't just count them. Okay? So here we need the distance formula, which we covered in the last section. The distance formula, I do the square root of my x's squared plus my y's squared. So T, I have a 0, and U, I'll look at TU, I have 0 -3. And my y's, I have -2 -5. So take this, or subtract those. I have -3 squared plus -7 squared. Remember, when you're squaring a negative, it becomes positive. So I'm going to have the square root of 9 plus 49, or the square root of 58. Okay. That gives me that TU is 7.62. Now, most times you would have to do the other line as well. Point out in this case, if you look, we have 0. We would have 0 minus -3 and -2 minus 5. So we're going to have the same exact thing in here. The only thing that changes is this becomes positive, which doesn't matter because of the squared. So both TU and TV are both 7.62. And if you realize that, you don't need to do the distance formula a second time, which makes my life a lot easier. So then my perimeter is 6 plus 7.62 plus 7.62, which gives me a perimeter of 21.24. Area of a triangle is 1/2 base times height. My base is VU, which is 6. My height is here. Your height always comes from a vertex and hits the opposite side at 90. That side is your base. So you could make VT your base and have a line come here, but then I have to do more distance formula. So here, coming down this way, I'm going from -2 to 5. So when I count that, I'm going to get 7. So then I'm going to get an area of 21. Okay. And remember units, this is 21.24 units. This is 21 units squared. I don't require units if they don't give me anything. And here we're just doing in the coordinate plane. So I would just leave it that way. But area is squared if we're doing units. Example 2. Tell whether the figure is a polygon. If it is not, explain why. If it is a polygon, tell whether it is convex or concave. It cannot be convex or concave if it's not a polygon because of our definition of convex and concave. So looking at these, the least obvious one is probably A, actually. A is no, because of this line in the middle. At both of these spots here, I have three lines meeting. That doesn't match our definition, which says each line intersects two sides, exactly two sides at the endpoints. So that is why that is not. You could look at it as two polygons put together, but for the definition of a polygon, it is not a polygon. B is yes. C is yes. And D is no because of the curve here. Okay, so our polygon is made up of lines. Lines are considered to not be curved in geometry, so that is no. Then they ask convex and concave. There's no point that goes in here, so this one is convex. Here we go in right there, so that is concave. Then when dealing with polygons, we have three more definitions here. The first one you've probably heard before, equilateral. All sides are congruent. Equiangular is all angles are congruent. What normally messes people up here is the term regular. Regular does not mean it looks normal, which is what most people think. Regular means that all your sides and angles are congruent. So, if we're dealing with quadrilaterals, a rhombus is equilateral because all sides are congruent. A rectangle is equiangular because all angles are congruent. Neither of those are regular. Okay, a rectangle, even though you're used to seeing it, is not regular because all sides aren't congruent. A square is regular. All the sides are congruent. And all the angles are congruent. All the angles are 90, sides are congruent. So make sure you keep that in mind. That trips people up a lot. Okay. Then the next thing, turn on the page, we have our different types of polygons. Okay. In our geometry book, these are also on page 30 in the book. So if you need to look them up, they are listed here. Most of these you know. 3 sides is a triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. 6 is a hexagon. I see a lot of people come up with weird names for both of these. 6 is a hexagon. 7 is a heptagon. Heptagon, I even see more weird names. I've even looked some of them up because I've seen them so much. They're not accurate. It is a heptagon. 8 is an octagon. 9, a lot of people are not familiar with 9, which is a nonagon. Nonagon. 10 is a decagon. And 12 is a dodecagon. Okay, deca is 10, so decagon being 10 makes sense. Do, if you think of like Spanish, dos, decagon, so 2 and 10 is 12, so dodecagon. Anything else we label as an n-gon. So if I have 15 sides, it's a 15-gon. If I have 35 sides, it's a 35-gon. We'll also do that with 11, is an 11-gon. Now I have seen decagon, UN, decagon, for 11, and that is an accurate name, so that is acceptable, but not generally what we will use in this class. So then looking at some examples related to classifying our polygons. Example 3, classify the polygon by the number of sides. Tell her whether the polygon is equilateral, equiangular, regular, or none. It says neither, but 3 choices, it should be none. And explain your reasoning. Okay. So, example A, I have 1, 2, 3, 4, 5, 6, 7, 8 sides. So that is an octagon. And it is regular because all the sides are congruent and all the angles are congruent. And I know that by how it's marked. B is a quadrilateral. Speaking of which, most people know quadrilateral, but they always come up with like other things because you know 4-sided shapes like square and rectangle. Remember, 4 sides is a quadrilateral. This is neither. Okay, I don't have the top and bottom marked, so I don't know what they are, so I can't say they're equal. They don't even look equal. And the angles are marked differently. So this is marked once, that's marked twice. That means those are not the same size. So it's not equiangular. Example 4 looks at solving this problem. The head of a bolt is shaped like a regular hexagon. The expressions shown represent the side lengths. Find the length of a side. So because they tell me it's a regular hexagon, I know all my sides are equal. Therefore, I can set 4x plus 3 equal to 5x minus 1. And then I can solve that. So I'm going to add 1 to both sides and get 4x plus 4 equals 5x. Then I'm going to subtract the 4x. I get 4 equals x. So my x is 4. Again, watch what they're asking for. Here they're asking for the length of a side. So I'm going to plug that 4 back in. It doesn't matter which one you plug it into. Whichever one you find easier. I'm going to do 5 times 4 minus 1. 5 times 4 is 20. Minus 1 is 19. And they also tell me this is in millimeters. So each side of that hexagon is 19 millimeters long. Final example. Example 5. The lengths in inches of 2 sides of a regular pentagon are represented by the expression 5x minus 27 and 2x minus 6. Find the length of a side of the pentagon. Okay, so again, same thing we just looked at. They just don't give me the picture in this one. They just give me the words. They say it's a regular pentagon. They tell me it's in inches. So these two are equal because it's regular. So I have 5x minus 27 equals 2x minus 6. So I'll subtract the 2x first here. I get 3x minus 27 equals negative 6. Add 27 to both sides. So 3x equals 21. Therefore, x is 7. And they say find the length of the side. So I'm going to plug that 7 back in. So we'll do 2 times 7 minus 6. Right? 2 times 7 is 14. 14 minus 6. And I get that my side lengths are 8 inches. So that is our polygons and the end of 1-4.